Hello everyone, this is Mr. M from Algebra Lessons. In this video, we are trying to prove these three problems because we have a time constraint of 15 minutes. We will finish only these three problems in this section. If you would like to watch more of the same kinds of problem, please try to subscribe this channel so you can watch continuous flow of these kinds of problems and other sections. Okay, let me go and find the proofs of these problems. Okay, let me start with a different color so things will be easier. Okay, the first problem is we need to prove sine to the power 4a minus cos to the power 4a plus 1 equal to 2 sine square a. Let me copy that problem here. Sine to the power 4a minus cos to the power 4a plus 1 equal to 2 sine square a. So the left hand side is LHS and the right hand side is RHS. So the left hand side, we are actually starting from the left hand side and prove the right hand side. So sine to the power 4a minus cos to the power 4a. So we are actually going to play with this piece. So think about the difference of square. We can express this piece in that format. So this can be write as sine square a to the power 2 minus cos square a to the power 2 plus 1. Wonderful. So this piece, sine square a the whole square minus cos square a the whole square. Suppose the sine square a is a, this is b, so this is in the form of a square minus b square. So we can write this as a plus b into a minus b. So that is actually the difference of square. A square minus b square can be write as a plus b into a minus b. So here a is sine square a, b is cos square a. So this will be sine square a plus cos square a. So this is a plus b into a minus b. That is sine square a minus cos square a. And we have a plus 1 outside. And you know that the identity sine square a plus cos square a is 1 and the leftover. So this will be 1 times sine square a minus cos square a plus 1. Okay, so I'm continuing the problem like here. So sine square a minus cos square a plus 1. So 1 times. So this is sine square a minus cos square a plus 1. And we know the identity sine square a plus cos square a equal to 1. And from this we can rewrite this cos square a equal to 1 minus sine square a. So that is the result we are using at this point. Okay, so in this piece of the problem, cos square a rewrite as 1 minus sine square a. So the problem now turned to sine square a minus of 1 minus sine square a and plus 1. Okay, so now open the bracket. So this will be sine square a. This negative and negative makes negative and positive makes negative 1. Negative and negative makes positive. So sine square a plus 1. And now look here, positive 1 and negative 1 got cancelled out. Sine square a plus sine square a is 2 sine square a. So this is the RHS, the right hand side. So we proved LHS is equal to RHS. So that is the proof of the first problem. What is the second problem? Second problem is cos to the power 6a plus sine to the power 6a equal to 1 minus 3 sine square A cos square A. So this is what we need to prove for the second problem. Okay, what you need to do at this point is pause the video for a moment and try to think what steps we can take to solve this problem or prove this. Okay. Okay, let me start the proof. So the LHS, the left hand side is cos to the power 6a plus sine to the power 6a. So like what we did in the previous problem, cos to the power 6a and sine to the power 6a, we can rewrite as cos square a to the power 3 plus sine square a to the power 3. And at this point, try to review your identities that you learned. See, suppose cos square a, assume this as a, and sine square a, assume this as b. So this is in the form of a cube minus b cube. Okay, so for your reference, we are going to use this piece of identity, a cube plus b cube. You can rewrite as a plus b into a square minus ab plus b square. So this is actually the identity that we are going to use in this problem. Okay, so I'm going to continue the problem right here. So the left hand side is cos square a the whole cube plus sine square a the whole cube. So a cube plus b cube is a plus b. A is cos square a. So cos square a plus b is sine square a, a plus b into a square, that is cos square a the whole square, that is cos square a the whole square minus ab, that is cos square a sine square a plus b square, that is sine square a the whole square. So that is the expansion. So this can be written as cos square a plus sine square a is 1, and the leftover inside the bracket is cos square a the whole square is cos to the power 4a minus cos square a sine square a plus sine to the power 4a. So that is actually the result we got after this step. And what you need to do is we can rewrite this with the help of an identity. So this is cos square a, cos to the power 4a minus cos square a sine square a. This is sine to the power 4a. So let me rebuild this piece like cos square a the whole square plus sine square a the whole square. Okay, this is a square plus b square. Okay, so to simplify this, we know the identity a plus b the whole square. A plus b the whole square is a square plus 2ab plus b square. Because here we have a minus sign, we can use a minus b the whole square. So that will be a square minus 2ab plus b square. So we have a square plus b square here. What is missing is this minus 2ab. So minus 2 sine square a cos square a. Wonderful. So this can be written as a minus b the whole square, right? So that will be so let me complete this piece. Okay, minus cos square a sine square a. Okay, this is a square minus 2ab plus b square, that is cos square a minus sine square a the whole square minus 2 sine square a cos square a we can write 2 sine square a cos square a plus cos square a sin square a will be 3 sine square a cos square cos square a. Okay, this is because we need the answer in so this could be right as 1. So how can we write that? Interesting. So at this point we can write this as did we miss something? Yeah, we missed something. That is, we added a minus 2 sine square a cos square a here to adjust that minus 2 sine square a cos square a, we need to add a plus 2 sine square a cos square a. Wow, sine square a cos square a. So combine these pieces. So that is cos square a plus sin square a the whole square. Oh yeah, we are there. So cos square a plus sin square a is 1 minus 3 sin square a cos square a. Yep, we are done with that proof. Wonderful. And now what I'm going to do is, let me move the screen a little bit down. Okay, give me a minute. Okay, for the last problem, it's an easy problem. So the question is square root of, yep, so the question is square root of 1 plus sine a by 1 minus sine a. We need to prove as sec a plus tan a. Okay, here we are actually going to use the procedure of rationalization. So let me use a different color. So rationalize the denominator. You guys already have this rationalization procedure before, so I'm not going further into that. I'm just going to the procedure. So square root of 1 plus sine a by 1 minus sine a, multiply both numerator and denominator with the conjugate of the denominator, that is 1 minus is 1 plus, so 1 plus sine a by 1 plus sine a. Okay, both of them have the radicals. Okay, so at this point you can check what is the numerator times numerator, that is 1 plus root of 1 plus sine a into root of 1 plus sine a can be write as root of 1 plus sine a the whole square. So that is take the radical of, so that is 1 plus sine a by root of 1 plus sine a into 1 minus sine a is a square minus b square, that is 1 square is 1 minus sine square a, that is equal to 1 plus sine a by root of 1 minus sine square a is root of cos square a, root of cos square a is cos a, that is 1 plus sine a by cos a, split this, that is 1 by cos a plus sine a by cos a. 1 by cos a is sec a plus sine a by cos a is tan a. So hence the proof. So we are done within our time limit. Okay, so thank you for watching this explanation video. So one suggestion, please watch the video by pausing in between and try to go through the explanation part. And one more time, thank you very much for watching this video. If you would like to get more videos of the same kind, please subscribe this channel and share with your friends. Thank you very much. Bye.